So, chapter 7 is all about solving two systems, or solving a system of linear equations using a graph, is what we start out with. Whenever you see the word solve in mathematics, we're usually looking for a specific answer. In our case, whenever we see the word solve, it means where the two cross. It's almost always going to be a coordinate, and that coordinate's important. Okay?
What is they? What is B?
There's going to be two lines.
Okay.
So solving a system of linear equations, your system of linear equations is basically a fancy way of saying two lines. So where the two lines cross is basically what we're asking you to do or find out. So if we have a graph, we have two lines in our graph. Let's go with, oh, I got black, that'll work. First line is somewhere over here. Second line is somewhere, we'll say right here. What we mean by where do they cross is somewhere that has a specific point. That's what we're looking for, okay? The way we can check this is we can take a point on either graph, and while this does solve one of our linear equations, it doesn't solve both of them. A place that solves both is where they cross. This makes more sense as we kind of get into it. I'll give you guys a couple seconds, but you're basically going to graph these two out and see where they cross. Y equals 2x minus 3. Y equals negative a third x plus 4. We'll give you guys about 3 minutes to try it out. X minus 3. We know we cross at negative 3. And I know my slope is 2, or rather 2 over 1. So I'm going up 2 and to the right 1. And for these solutions, you kind of want to graph these as accurately as possible. I'd strongly recommend using a ruler. For our second equation, we cross at positive 4. With a slope of negative 1 over 3. So we're going to go down 1 and to the right 3 every single time. Most of my examples I'm going to give you guys that have a solution are going to cross kind of at a nice point where you can see the coordinates very easily. The first example I gave you guys, this guy, wasn't very good. Most of them would be like this. So we can see these cross at the point, what's that? 1, 2, 3, so 3 and 3. So that is our solution to our graph. And if I'm asking you to just please solve this, that's all I'm looking for is those coordinates. Most of the time, I'm going to ask you to check your answer. We do that by plugging that point into both equations. When I put the point 3 and 3 into an equation, if my left side and right side will equal the same number at the end, we know that that point is on the graph. I'm going to show this with both 3 and 3 for both of these. I'm also going to pick a random point and show why it won't work. Yeah, that's fine. So for the first equation, y equals 2x minus 3. We're going to check the point 3 and 3. So I know that my x is 3, my y is 3. So really this becomes 3 equals 2 times 3 minus 3. 2 times 3 is 6. So we have 3 equals 6 minus 3. 6 minus 3 gives us 3. So my left side and right side equal out. So I know that the point 3 and 3 is on that first graph, which it should be. I can visually see that it is. I have y, bless you, y equals negative 1/3 x plus 4. And again, punch in the point 3 and 3 into both sides. Excuse me. So my y is 3, my x is 3. So 3 equals negative 1/3 times 3 plus 4. Should work. Okay, when I multiply this out, negative 1/3 times 3 is what? Or rather, what's 3 times negative 1? So we have negative 3 divided by 3 plus 4. Negative 3 divided by 3 turns into negative 1. And negative 1 plus 4 gives us 3 and 3. So we know it works out. If I works on both graphs, as soon as I know they're not parallel, they've got different slopes, the only point at which they would share that same point is where they would cross. So it has to be the solution. You're going to find, or please solve, x plus y equals 5, and x minus y equals 1. Exact same answers. So again, we rearrange, so it's in slope-intercept form. You graph them, see where they cross, and when you plug it in to check your answers, you can plug it into either your original equation or your rearranged equation. Doesn't matter. Homework is on page 409, questions 3 to 7.
That's it?
That's it.